Welcome back, ladies and gentlemen. Today we're going to be taking a look at our practice test for our upcoming test on right triangles and similarities. So let's begin. Given the following three sides of a triangle, classify the triangle as acute, obtuse, right, acute, obtuse. Okay. So the hardest part here is you have to figure out what the C value is for all of these. Root 11, 5, and 7. So my C is going to be, 7 there. And what I want to do is I'm running Pythagorean theorem. Okay, so if I do that, I'm looking at, this will be my A, so root 11 squared plus 5 squared, and I'm trying to see if it equals 7 squared. If you put square root of 11 into my calculator right here, square root 11, and I square that, I will get actually 11. Okay, so 11 plus 25 equals 49. See if it equals. 11 plus 25 gives me 36. Now, 36 is less than 49. Now that means that my C squared is bigger, so therefore that is an obtuse triangle. Okay? You must show the work. If you write down just obtuse on the test, you will be incorrect. Okay, just a friendly heads up. 15 squared plus 20 squared, see if it equals 25 squared. Okay, so what we're doing here is we're going to go ahead and say, all right, 15 squared plus 20 squared, 625. Okay, and if I do 25 squared, I get 625 as well. If they equal each other, right triangle, good to go. Okay. All right. 21, 23 root 2, and 40. 21 squared plus 23 root 2 squared. See if it equals 40 squared. All right. 21 squared plus, make sure you put parentheses around this, 23 root 2. And then close parentheses again, squared. Gives me 1499. And 40 squared should be 1600. So since C squared is bigger, that's obtuse. Good. And finally, 13.1 squared plus 14.2 squared. See if it equals 15.3 squared. All right. Just more of the same here, 13.1 squared plus 14.2 squared. That gives me a 373.25, and that's 234.09. My A squared plus B squared is bigger, therefore it's in a acute triangle. Okay? Cool. All right. So, moving down a little bit, use the following diagram to find the missing side length of the right triangle. All right, we're using Pythagorean theorem here. Across from your 90 will always be your C. So, 5 squared plus 12 squared, because honestly my A and my B don't matter, they're interchangeable, equals x squared. Okay. 25 plus 144 equals my x squared. So, 169 equals x squared. I have to square root both sides, and when I do that I will get 13. Okay, so we're good. If it were to ask you if this is a Pythagorean triple, yes, this is a triple. I know it's not in the directions here, but you get the idea. Please note the difference for part B. Across from my 90 is 23. That'll be my C. So now x squared plus 11 squared equals 23 squared. Okay. X squared plus 121, see if it equals 23 squared. Well, we know it equals that, so it's 529. We have to do an extra step here where I have to minus 121 from both sides. So 529 minus 121 gives me 408. Okay. Square root left, square root right. And we're going to get x equals 20.199. Okay. hard to see. Yeesh. Okay, which rounds to 20.2. Because we're going to ask you to go to the nearest 10. Okay? Alright. Very good so far. Again, you guys are doing a great job with that. Given the following three side lengths of a triangle, 13, 14, 15, we can classify the triangle as an acute triangle. So what they're saying here is a squared plus b squared is bigger than 15 squared. How could you change one of the sides to create an obtuse triangle instead? Well, this is kind of more of like a you play with it kind of thing. I'm going to just try something out here. I'm going to keep 13 and 14 the same. Now, what I am going to do is add them together. 13 plus 14 is 27. I need the third side to be bigger than, or I'm sorry, to be less than 27. Okay, because it has to pick these two sides to be bigger than them. So I'm going to pick a number like 25, because that's 27. 27 is bigger than 25. That's fine. Let's see if this works out. Here's my A, B, C. 13 squared plus 14 squared. See if it equals 25 squared. My goal here, if I want obtuse, is that I want this to be bigger than it. So 13 squared plus 14 squared. 25 squared. Jackpot. So 365 is less than 625. So we have just created an obtuse triangle. Just a friendly heads up. If all three side lengths are close to each other, normally acute. If one's really, really far apart, that's normally obtuse. Okay, just in general. All right, on the back here, okay, we have a lot of word problems. The foot of a ladder is placed 7 feet from a wall. So here is my wall. There is my ladder leaning up against it. So this is 7. If the top of the ladder rests 13.5 feet up the wall, how long is the ladder? Okay, so there is my right angle. There's my C. This is just Pythagorean theorem. So we're looking at 7 squared plus 13.5 squared equals x squared. Okay, good old-fashioned calculator work. 7 squared plus 13.5 squared gives me 231.25. Okay, I'm going to square root that. 15.2 feet. Okay, so square root left, square root right. Good. Okay. Alright. Now, please note the difference for part number 5. The foot of a ladder rests 4.2 feet from a wall. Ooh, this sounds very similar. Okay, so there's my building. There's my ladder. Here is my 4.2. The ladder is 21 feet long. So, that's 21. Now this is my x. Okay, so if I go across, notice that now 21 is c. So if we take a look at this, we're looking at x squared plus 4.2 squared equals 21 squared. The difference here is x squared plus 17.64, 21 squared is 441. We have to subtract the 17.64 from both sides. Okay, so x squared equals minus 17.64, 423.36, square root, x equals 20.6 feet. Okay, again, a really tiny thing makes a very big difference. Okay. These are 2 challenge problems, just to give you guys a little bit of a heads up. The area of a square is 36 square inches. Well, guys, the area is equal to s squared. So if they're telling you this is 36 and you're trying to find what the side length is, square root the area. That tells you the square of 36 is 6. So what that means is this is going to be 6, 6, all the way around to 6. Find the length of this side. We've got that. Then find the length of the diagonal. Well, okay, we can just do Pythagorean theorem here, or, since we know this is 45, 45, 90 triangle, x root 2, 6, 6, 6 root 2, okay? Really simple. If you were to use Pythagorean theorem, you would get an answer of 8.5, okay, and that's in inches. So either one's fine, all right. If you're going to use Pythagorean theorem, go for it. You would just do 6 squared plus 6 squared equals x squared, and you'd get the same answer either way. Same idea for number 7. The area of a square is 121 square meters. So again, a equals s squared. If I square root 121, I get 11. So 11, 11, the diagonal would just be 11 root 2, because of 45, 45, 90 triangle. Or if you were to run Pythagorean theorem, we would get 15.6 meters. Okay? So again, either answer is acceptable. We're good to go. Last part here, we spent some time on this in class, and I want to make sure I kind of remind you guys. Find the missing values of variables using knowledge of special right triangles. You have to recognize if it's a 45, 45, 90 or 30, 60, 90. Hopefully it's pretty simple because 45 is here, that must be 45 as well. The ratios we talked about in class, go across from 45, put x. Go across from 45, put x. Go across from 90, put x root 2. Now, if you really wanted to, you could show all of this work. Divide by root 2, x equals 10 over root 2, rationalize top and bottom. I know I'm going really quick here, but running out of time. Square root of 2 times square root of 2 is square root of 4, which is 2. This cancels out to be 5 root 2. Therefore, each of these is 5 root 2. But the shortcut is, if I'm giving you the hypotenuse of a 45, 45, 90 triangle, divide it by 2, and put root 2 behind it. So for example, on the test, if this was, say, 20, 20 divided by 2 would be 10. So it would be 10 root 2, 10 root 2. It's that simple. Okay? Really that simple. 30, 60, 90 triangle, okay? Across from 30, now this ratio is a little bit different. Across from 30 is x. Across from 60 is x root 3. And across from 90 is 2x. Oh no, a equals x. That's not good. But right here, see how I have 5 root 3 equals x root 3? What does x have to equal? 5. So that means my a up top has to be just 5, and my b has to be just 5 times 2, which is 10. Okay? So again, I know special right triangles are confusing, but they're meant to be shortcuts. They're meant to be easier, right? So keep up the good work as always, and good luck. We're all counting on you.